Example 1.24. Okay, it's a very important 10 mark question. So we have to solve and find out x, y, z, and we also have to prove that the system is consistent, and we will be using the rank method for this. So let's get started. So whenever we have three set of linear equations, the first thing we will do is we will write it in matrix form. So I'm just checking the coordinates of a, b, and x, y, and z, and I'm writing the matrix here. So the second equation will be 1, 2, 3, and the third equation will become, right, 1, 4, 7. This, when we multiply with x, y, and z, the resultant that we get is this 6, 14, 13. 6, 14, and 30, right? So this I can call it as A, this is B, and this is X, and this is B. So if you remember in inversion method, whenever we say AX equal to B, we will solve for X saying that X is equal to A inverse B. But now we are going to solve using the rank method, right? So for the rank method, the first step that we will be writing is to write the augmented matrix. So what does augmented matrix mean? This is nothing but we will be combining the A and B matrix together, right? So now my combined matrix will become 1, 1, 1, 6, 1, 2, 3, 14. I'm just writing from here, and the third row will become 1, 4, 7, and 30. Okay. Now, you know that whenever this we will try to solve it in the rank method, and so we have to bring it to the echelon form. Whenever we try to bring it in the echelon form, we ensure that the first row, first column element here is 1. Right, here it's already 1, so we can proceed to the next step, that is to make the second row, first column, this element here as a 0. What should I do to make this a 0? I'm proceeding here. So I'll write the first row as it is, right? 1, 1, 1, 1, 1, 6, right? The next row, I'm going to say R2 is equal to R2 minus R1. So this now becomes 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2, and 14 minus 6 is 8. Likewise, I'm going to say R3 is equal to R3 minus R1, because in echelon form I also want to make this a 0. So this now becomes 0, 4 minus 1, 3, 7 minus 1, 6, and 30 minus 6 is 24, right? Now, in the next step for echelon form, we want to make now this element here as 0, right? There are two options. I can multiply row 1 by 3 and say 3 minus 3 is 0. In that case, what would happen is this element here will become 6 minus 3, 3, and 24 minus 18, which will be 6. But consider the other option. If I am going to say 3 minus 3 times R2, then this entire row will become 0. So let's see how it happens, right? So let's write the first two rows as it is. We are going to say R3 is equal to R3 minus 3 times R2, right? We are doing this to make the entire row here as 0. So it will be 0 minus 3 times, 1 here, so it's anyway going to be 0. 3 times 0 is anyway 0 here. Then 3 minus 3 times 1, which is 0. 6 minus 3 into 2 here, again 0. And 24 minus 8 into 3, which is 24. So 24 minus 24 is 0. So now you see that you have got it into the echelon form, and also the entire row here has become 0. So now what is the rank of A and B, right? The rank of A and B is 2. That's because you have only 2 non-zero rows in your matrix. And what is the rank of A? The rank of A is also equal to 2. How do I get the rank of A? I take only the A matrix, this matrix, right? What is the rank of this matrix? It is also true because there are only 2 non-zero rows in A. Therefore, how do we say that the system is consistent? So when the rank of A comma B is equal to rank of A, then we say that the system is consistent, right? This is what we had to prove also. But now we also have to find the values of x, y and z. So how do we do that? If the rank of the matrix, okay, this is the next rule that we're going to see. If the rank of the matrix, right, A comma B, or even the rank of A, okay, which is 2 here, this is less than the number of unknowns, which is 3. What do I mean by number of unknowns? X, y and z, right? These are the 3 unknowns which we have to find. Since the rank of your matrix is lesser than the number of unknowns, the system can be said to have infinite number of solutions, right? So just get this clearly. If your rank of your matrix is lesser than the number of unknowns, then the system can be said to have infinite number of solutions. So now if I am going to write this matrix that we got it in echelon form, right? This matrix here 1 1 1 0 1 2. If I write it in the form of a matrix equation, it would be like this, right? So it would be 1 1 1 0 1 2 0 0 0. This when I multiply with x, y and z, the resultant I get is 6, 8 and 0, right? What I have done is I have just written this matrix, this augmented matrix here in echelon form into a matrix equation form, right? So now shall I write this into the equation, a linear equation, xy plus z is equal to 6, y plus 2z equal to 8, and third equation I can't write it, it's anyways 0. So from this third equation, can I say that y is equal to 8 minus 2z, right? So I'll mark this as the first equation and this as the second equation. So from the first equation, right, I can say that x is equal to 6 minus z minus y. But I know that y is equal to 8 minus 2z, so I'm going to say x is equal to 6 minus z minus y, right? So it becomes minus 8 plus 2z, and this is nothing but z minus 2, right? So I get y is equal to 8 minus 2z and x is equal to z minus 2. So if I am going to say let z equal to k, where k is going to be a real number, right? So k is going to be a real number. I can say x is equal to k minus 2 and y is equal to 8 minus 2k, right? And if I say, I'm going to substitute, right, let k be equal to 1, then I will get x is equal to minus 1 and y is equal to 8 minus 2, which will be 6, and z of course will be k, so z will be equal to 1. So for different values of k, you will be getting different solutions, right? So you need not write for all the different solutions. You can just sample for k equal to 1, but you have to mention that for different values of k you will get different solutions. Therefore the system has infinite number of solutions, right? So let me quickly recap what we have done. So we had to prove that the system was consistent. So what we did was we have first written this in a matrix form, and then we wrote the augmented matrix, that is A and B together. So once we got the augmented matrix, we tried to bring it to the echelon form. Once we brought it to the echelon form, we saw that the rank of A and B, the augmented matrix, is equal to the rank of A alone, which is 2. Right? Therefore, the system, when the rank of A and B is equal to rank of A, the system is said to be consistent. And what is next? We had to find out x, y and z. Since the rank of A and B, which was 2, is lesser than the number of unknowns x, y and z, the system is said to have infinite number of solutions. We just can't stop here. We have to find at least one solution, right? because this is a 10 mark sum. So what we did was, we wrote this into the matrix equation form. We wrote the echelon form matrix in the matrix equation form, and then we got two equations here. Since we had two equations and we had to find out three unknowns, we brought z equal to k, and where k is an element of a real number. It's a real number, it can be any value, and we substituted for z equal to k, and we got x and y in terms of k. And then when we substituted, for example, k is equal to 1, we wrote what could be the possible solution. But likewise, you can put any value of k and you can get different solutions. Therefore, you can say the system has infinite number of solutions.